The gummy candy was born in the kitchen of German confectioner Hans Riegel. For over a year, he made candies with nothing more than a copper pot and a stove. Eventually, he struck gold with the gummy bear. The process of candy making starts with preparing a recipe that will be followed to the letter in the production process. For this purpose, companies employ experienced food technologists and expert chemists who know what they're doing. When developing the formula for gummy candy, they experiment with the proportions of the different ingredients in order to influence the taste, texture, and appearance of the candy. The main ingredient responsible for the characteristic texture of gummy candy is gelatin. If you've ever wondered how the candy dissolves in your mouth, it's because of gelatin's thermoreversibility. To speak in simple terms, gelatin becomes thinner the more heat it absorbs, allowing it to disintegrate as soon as it enters your mouth. Although it's the main ingredient, gelatin is tasteless and odorless. Therefore, sweeteners and flavorings are added to the candy to give it a taste. Commercially, both sucrose, derived from sugarcane, and fructose is used, although the latter imparts much more sweetness. To stop the sugar from crystallizing in the candy, corn syrup is added. Apart from that, corn syrup gives the candy more volume and maintains its moisture content. Gummy candy doesn't taste just sweet though, does it? Natural flavors are added to help build the flavor profile of the candy. These are obtained from fruits, berries, molasses, and maple sugar. The impact of these flavors is made more powerful by mixing them with aromatic chemicals, giving them the smell we associate with each of the flavors. The candies are given color with the help of natural dyes. Typical dyes include red dye number 40, yellow dye number 5, yellow dye number 6, and blue dye number 1. Using these regulated dyes, gummy manufacturers can make the candy in almost any color they desire. Finally, natural acids are added to control the pH of the gelatin. This is important because the texture of gelatin depends on a variety of factors, including temperature, method of manufacture, and pH. While the rest of these can be controlled physically, food-grade acids help manufacturers control the pH chemically. Now that the ingredients have been sorted, we can proceed with manufacturing. The manufacture of gummy candies begins with compounding. In this process, the factory workers follow the recipes prepared by the food technologists and physically pour the correct proportion of the ingredients into mixing tanks. These tanks, which are equipped with mixing, heating, and cooling capabilities, are quite large. After the ingredients have been thoroughly mixed, they undergo a continuous heating process, allowing the gelatin to dissolve completely and for the flavors to develop. While in the tanks, the mixture is continuously stirred to prevent burning and ensure even heating. After the candy base has been compounded or cooked, it is transferred to a specialized machine known as a mogul, which uses starch as a molding base. The mogul machine operates continuously and automates multiple tasks in the candy-making process. Starch, a crucial ingredient in the process, serves various purposes, such as preventing sticking, holding the candies during drying and cooling, and absorbing moisture to create the desired texture. For the starch molding process to start, it is first filled into empty trays, leveling the surface. The trays then move to a printer table where a board with molds imprinted on it presses the starch, creating indents that match the desired candy shapes. The gummy candy base prepared during the compounding process is transferred to the depositors within the mogul machine. The depositors consist of filling nozzles that deliver precise amounts of the candy base into the trays filled with starch molds as they pass under them. The depositors can accommodate multiple colors and flavors simultaneously, streamlining the production process. Filled trays are moved to a stacking machine and then transferred to a dedicated cooling room. The candies remain in the cooling room for over 24 hours, allowing them to properly cool and form their desired texture and shape. Cooled trays of gummy candy are then inverted within the mogul machine, causing the candies to fall onto a vibrating sieve. This sieve, along with oscillating brushes, removes excess starch from the candies. The cleaned candies are then conveyed to other machines for further decoration and packaging. In commercial production, additional steps may be taken to enhance the appearance and taste of the gummy candies. This can include applying a thin layer of wax or polishing agents to give the candies a shiny finish. Some candies may also undergo a sugar or sour coating process for added texture and taste. The finished gummy candies are automatically sorted, inspected for quality, and then packaged into various forms of packaging, such as bags, boxes, or jars. Automated machines handle the packaging process, ensuring efficient and consistent packaging of the candies. Quality control begins with the evaluation of the incoming raw materials. Before they are used, these ingredients are tested in the QC lab to ensure they conform to specifications. Various sensory characteristics are checked, including appearance, color, odor, and flavor. Many other characteristics, such as the particle size of the solids, viscosity of oils, and pH of liquids, are also studied. Each manufacturer depends on these steps to certify that the ingredients will produce a consistent, quality batch of gummy candy. The characteristics of each batch of final product is also carefully monitored. Quality control chemists and technicians check physical aspects of the candy that include appearance, flavor, texture, and odor. The usual method of testing is to compare them to an established standard. For example, the color of a random sample is compared to a standard set during product development. Other qualities, such as taste, texture, and odor, are evaluated by sensory panels. These are made up of a group of people who are specially trained to notice small differences. According to estimates, 160 million gummy candies are produced in factory floors around the world each day. Well, for a process that long, I'd say the reward is well worth it. When crayon production started in America back in the 1900s, lots of different companies competed for the incredibly lucrative art supplies and schools market. However, one company emerged as the market leader in 1903. Almost 120 years later, they are still at the top of the orange tree. Everyone who has ever used crayons knows the Crayola brand, and the name itself was coined by Mrs. Alice Binney, the wife of one of the company's founders. According to a statistic, the Crayola company produces an average of 3 billion crayons per year. That's 8 million crayons per day. Just to give you an idea of how large that number is, if you were to lay these crayons side by side, they would be enough to go around the world 6 times. Crayon production has developed a lot in the past 120 years. In the 1900s, you could only get crayons in 8 different colors. Fast forward to today, and that number has gone from 8 to 120 dazzling colors. But how are they made? Crayons are made from a material called paraffin, a waxy substance derived from wood, coal, or petroleum. Not only is paraffin compatible with a large number of pigments, but it's also non-toxic and safe for use, making it perfect to make crayons with. It also has what is called a nice rub-off, meaning that it leaves enough wax on the paper. Paraffin is delivered to the crayon factory in liquid form. Delivery trucks must maintain a warm enough temperature to keep the paraffin from hardening. Paraffin becomes liquid at about 135 degrees Fahrenheit, 57 degrees Celsius. The next crucial material in crayon production is the pigments that give the crayons their color. Because paraffin will not mix with water or water mixtures, the pigments are in powdered form, although they may have been made from a water mix and then dried. Pigments are made by suppliers following formulas dictated by the crayon manufacturer. Individual pigments are made of chemicals mixed together in wooden tanks and forced through filters to remove excess water, leaving chunks of the individual pigments. The pigments are then kiln dried for several days. After drying, the chunks of pigment are mixed according to the formula for the desired color, pulverized into a powder, and blended for color consistency. The mixes are sent to the crayon factory. Over the past 10 years, additional ingredients have been added to crayons. One of the most popular is glitter, small pieces of reflective material that make the crayon-produced work shine as it catches and reflects random beams of light. Perfumes and other scents can also be added to the mix. To kick off production, paraffin is heated in large industrial boilers at around 82 degrees Celsius until it turns into a liquid. The temperature and heating time are precisely controlled to ensure the safety and quality of the process. The paraffin is then transferred into huge silos which can hold up to 65,000 liters, more than the maximum takeoff weight of the Sikorsky King Stallion, one of the biggest helicopters in the world. If you think this is too huge an amount, remember that a typical crayon factory uses this much in just a day. Because paraffin is a flammable material, strict caution is exercised to ensure safe storage. Workers handling paraffin usually do so while wearing breathing masks to avoid inhalation of fine particles. Paraffin is moved from the storage towers to mixing kettles, where it is mixed with clay. Not only does this give the crayons more strength, but it also acts as a filler, boosting the number of crayons the wax will produce, making the whole process that much more cost-effective. After that, various synthetic chemicals are added to the mix. There's one to prevent the mixture from sticking to the mold. Additionally, stearic acid is also added to increase rub-off. Finally, powdered pigments are added to the mixture. These are of the highest quality to ensure vibrancy and consistency of colors. Keep in mind that all the ingredients added to the mixture so far are non-toxic. The mixture inside the kettles is kept at a consistent temperature to ensure that the pigments are completely mixed with the paraffin. The mixture is also thoroughly stirred to ensure an even distribution of color. Once the wax and pigment mixture is well blended, it is pumped into a device called a rotary machine. To keep the paraffin from hardening, the temperature is controlled. The device first injects the wax into molds. These molds can vary in size and shape, depending on the type of crayon being produced. The molds may be of metal or silicone and are designed to create the familiar cylindrical shape of a crayon. Cool water envelops the molds, hardening the wax inside them within 60 seconds. The cooling process is crucial for the crayons to maintain their shape and structural integrity. As the wax solidifies, it captures the color pigments, resulting in the final vibrant hues of the crayons. The wax at the top of the molds is scraped off with a specialized blade that can be recycled and used in the production of new crayons, reducing waste in the manufacturing process. Just one rotary machine produced 2,700 crayons in each of its cycles. With several rotary machines working in unison, a typical factory produces 30,000 crayons every hour. After cooling, the crayons are automatically pushed out of the molds and inspected. Inspectors examine each crayon for breaks and chips, as well as signs of bubbles in the cooled crayon, a condition that occurs if mixing has not been complete. Rejected crayons are returned to the tubs for remelting and recasting. In the early days of crayon manufacture, an entire factory floor might be devoted to the production of a single crayon for a day or more. Following that color's molding, machines would be cleaned and a new color would be made. In today's factory, the demand for crayons is so huge and the number of different crayons so great, easily more than 100, that individual vats and molds are dedicated to only one or only a few colors, and the production lines run day and night. After the molding and inspection process is complete, a conveyor transports the crayons to the labeling machine. One by one, they drop into the grooves of a revolving drone. At the bottom left, glue coats the surface in between the grooves, just before the crayons go in. The machine then slaps a label onto each crayon. A roller then presses the label against the adhesive. Then a small arm wraps it around the crayon. This machine can label 8,500 crayons per hour. To reach the daily production quota for the factory, several of these machines are used. Quality control is a critical aspect of crayon production. Therefore, a final check takes place just before packaging. Random samples from each batch are tested for color accuracy, hardness, and other specifications. This ensures that the crayons meet the desired standards and that any defects are identified and addressed before packaging. Once the crayons pass quality control, they are ready for packaging. Crayons are typically packaged in cardboard boxes or plastic containers, and the packaging may include additional information, such as color names, usage instructions, and safety warnings. The packaging process is automated, with machines counting and sorting crayons before placing them in their final packaging. Packaged crayons are then prepared for distribution. They are boxed and palletized for shipment to retailers, schools, and other distribution points. This stage involves logistics coordination to ensure that the crayons reach their destinations in a timely and cost-effective manner. Well, that marks the end of the journey of a crayon. If you're curious about how other household things are made, check out this video.